Okay, dear students, let's see what is electric field. Today's lecture we will discuss what is electric field, what is electric field strength, and what is electric field lines and properties of electric field lines and electric flux. Okay, then what is electric field? First is what is electric field. So till this what we had discussed, what is electric charges. Okay, from now we have to discuss what is electric field. So electric field means every electric charges experiences a electrostatic force. See here, I am taking a positive charge here. Okay, it is your positive charge. Around of this the electric field will be there. Okay, it is very important. See here, I am taking a positive charge over here. If it is a positive charge, it is around of this the electric field will be creates. Okay, how electric field will be creates? Because of electric field lines. Okay, so if it is a positive charge, the electric field lines are radially outward. So electric field lines are generated from electric charge. See here, if I take negative charge, the electric field lines are always radially inward. If there is a positive charge, the electric field lines are radially outward. If there is a negative charge, the electric field lines are radially inward. Okay, na? Positive charge radially outward, negative charge radially inward. Okay, so what is electric field first? So electric field is a reason. Electric field is a reason the charge particle experiences a electrostatic force is called your electric field. Okay, na? What I told electric field? Electric field is a region around the electric charge. This experiences a electrostatic force is called your electric field. ಏನಂತ ಹೇಳಿದವನು? ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಂತಂದ್ರೆ ಏನು? ಈ ಚಾರ್ಜ್ ಅರೌಂಡ್ ಜೊತೆಗೆ ಒಂದು ಫೀಲ್ಡ್ ಕ್ರಿಯೇಟ್ ಆಗುತ್ತೆ. ಹೌದಾ? ಈ ಫೀಲ್ಡ್ ಕ್ರಿಯೇಟ್ ಆಯ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ಇಲ್ಲಿ ಈ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಏನ್ ಮಾಡುತ್ತೆ? ಒಂದು ಫೋರ್ಸ್ ನ ಕ್ರಿಯೇಟ್ ಮಾಡುತ್ತೆ. ಅದು ಯಾವ ಫೋರ್ಸು? ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್ ನ ಕ್ರಿಯೇಟ್ ಮಾಡುತ್ತೆ. ಸೊ ಆ ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್ ನ ಕ್ರಿಯೇಟ್ ಮಾಡುತ್ತೆ. ಹೆಂಗ್ ಕ್ರಿಯೇಟ್ ಮಾಡುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಇದು ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ ಯಾವಾಗಲೂ ರೇಡಿಯಲಿ ಔಟ್ವರ್ಡ್ ಇರುತ್ತೆ. ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ರೇಡಿಯಲಿ ಔಟ್ವರ್ಡ್. ಹೌದಾ? ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ ರೇಡಿಯಲಿ ಔಟ್ವರ್ಡ್ ಆಯ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ಇದ್ರ ಸೀದಾ ಒಂದು ಸರ್ಕಲ್ ಹೊಡೆದ್ರೆ ಇದಕ್ಕೆ ನಾವ್ ಏನಂತ ಕರಿತೀವಿ? ರೀಜನ್. ಅರೌಂಡ್ ದಿಸ್ ಏನಾಗುತ್ತೆ? ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್ ಆಗತ್ತೆ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಇಟ್ ಈಸ್ ಇಫ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ನಾನು ತಗೊಂಡೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ತಗೊಂಡ್ರೆ ಏನಾಗುತ್ತೆ? ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಆರ್ ರೇಡಿಯಲಿ ಇನ್ವರ್ಡ್ ಅಂತ ಹೇಳ್ತೀವ. ಸೊ ರೇಡಿಯಲಿ ಇನ್ವರ್ಡ್. ಹೌದಾ? ಈ ತರ. ಸೊ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಔಟ್ವರ್ಡ್, ನೆಗೆಟಿವ್ ಇದ್ರೆ ಇನ್ವರ್ಡ್. ಓಕೆ, next is electric field strength. What is electric field strength? Or electric intensity. What is electric field strength and or electric intensity? See here, what I told, if I am taking a positive charge over here, assumption charge I am going to consider here. What is assumption charge? I am keeping assumption charge. It is test charge Q naught here. These two are separated by a distance R. Okay, this electric charge experience a force on this. Which kind of force that is? That must be electrostatic force. Okay, if this charge experiences a force on this, that must be electrostatic force. Okay, on which the electrostatic force is applied. acting on this. So this electric field E is equal to force experience on unit test charge force, on which the force is experienced. It is unit charge q naught, unit charge q naught. So it will be force divided by unit charge q naught, or else test charge you can take. Okay, let's take it is test charge. It will be your test charge. So this electric field is equal to, what should I write? Force, electrostatic force it is. Which kind of force it will be? Electrostatic force. So what will be our formula? It is K Q naught divided by R square, because of Coulomb's law, into Q naught shall I write? Divided by means what? A divided by B divided by C, means into Q naught get cancels. So what is the main formula for electric field? It will be KQ by R square is the important formula, remember. Okay, it is about your electric field. What is the SI unit of electric field? How to calculate SI unit? So SI unit of electric field. Okay, what is? So this SI unit is equal to SI unit of electric field. So this electric field is equal to, what is our formula? Force divided by test charge. It will be force divided by Q naught. I am writing. What is the SI unit of force? It will be Newton, divided by Q naught, charge, SI unit of charge. It will be Coulomb. So SI unit of electric field will be Newton per Coulomb. Okay, it is about electric field strength and electric intensity. See, as I write here, E is equal to KQ divided by R square I write. Okay, so it always holds good inverse square law. So E is inversely proportional to 1 by R square. As the electric field is increases, as the electric field strength is increases, distance must be decreases. Okay, as the distance is increases, electric field must be decreases. Okay, so as the electric field decreases, R must be increases. So diagram for this is, let us see, it will be electric field, it is your R. As the electric field is decreases, then distance must be increases. Okay, so this is your graph. Electric field is decreases, R is increases. Okay. R is decreases, electric field is increases. So electric field is always holds good inverse square law, and electrostatic force, Coulomb's law, is also holds good inverse square law. Okay, next, see the next. Electric field due to number of charges. Electric field due to number of charges. Number of charges. Okay, just itself only I took only one charge, one is a test charge. If there are number of charges experiences a electric field and test charge. So see here I am taking assumption charge, that is test charge Q1, Q2, Q3, Q4, Q5 up to there are Qn number of charges. So Q1 experiences a force along this direction, I am taking R1, Q2, R2, Q3, it will be R3, Q4, R4, Q5. If there are n number of, it will be R of n. First, write for E1 electric field. We know the formula E is equal to KQ by R square. Remember this. KQ is KQ divided by R square. Then this E1 is equal to K Q1 divided by R square. Then this E2 is equal to K Q2 divided by R2 square. It will be R1. So E3 is equal to K Q3 divided by R3 square. Then if there are n number of charges, then En is equal to, what should I write? K Qn divided by Rn square. Okay. So net force acting on this. So here E net force acting on this test charge must be, what should I write? K E1 plus E2 plus E3 plus E4 up to En. Okay, up to En. Then this E net is equal to K Q1 by R square plus K Q2 by R1 square R2 square plus K Q3 by R3 square up to K Qn divided by Rn square. Then this E net is equal to, what is the common factor here? K is a common. So K is a common. I am writing Q1 divided by R1 square plus Q2 divided by R2 square up to Qn divided by Rn square. So it can be written as this E net is equal to, K is a common, summation of n is equal to 1 to n, it will be Qn divided by Rn square. This is the important formula. If there are more than 2, 3, 4, 5 n number of charges, our formula will be K, summation of n is equal to 1 to n, Qn divided by Rn square is the final expression. Electric field due to number of charges. If there are more than 2, 3, 4, 5 number of charges. So first of all, electric field E1 is equal to KQ1 by R square, E2 is equal to K2 by R square up to En is equal to KQn by R square. Then E net is equal to E1 plus E2 plus E3 up to En. So KQ1 up to, so E net is equal to, K is a common, take it outside. Write in summation, Kn is equal to 1 to n Qn divided by Rn square is the final expression. Okay. Next, what is electric field lines? Next is electric field lines. Next is electric field lines. What are electric field lines? So electric field lines may either straight or a curved path in the electric field. The direction of the electric field can be calculated, can be understood by drawing a tangent to the electric field lines. ನಾನು ಏನು ಹೇಳಿದೆ, ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ಗಳು ಸ್ಟ್ರೇಟ್ ಅರ ಇರಬಹುದು ಅಥವಾ ಕರ್ಡ್ ಪಾತ್ ಒಳಗರ ಇರಬಹುದು. ಆದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್, ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಯಾವ ಕಡೆ ಐತಿ ಅಂತ ಗೊತ್ತಾಗಬೇಕು ಅಂದ್ರೆ ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ, ಅದ್ರ ಜೊತೆಗೆ ಒಂದು ಟ್ಯಾಂಜೆಂಟ್ ನ ಡ್ರಾ ಮಾಡಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ ನನಗೇನು ಗೊತ್ತಾಗತ್ತೆ, electric direction of electric field ಗೊತ್ತಾಗುತ್ತೆ. ಓಕೆನಾ? See here, if it is a straight line, the electric field will be along this direction. Okay, if I take curved path, so in this case, if I want to understand the direction of electric field, I want to draw the tangent to this curve. See here, at this point, if I draw a tangent, the electric field will be along this direction. At this point, the electric field will be along this direction. At this point, electric field will be along this direction. At this point, electric field will be along this direction. What I told, electric field lines either may straight line or else in a curved path. In the electric field, the direction of the electric field can be understood by drawing a tangent to the curved path. Is called your electric field lines. Then, if there is only a 1 point charge, positive charge, how to draw? So, if here a positive charge is here, okay, if it is a positive charge, suppose draw like this. If there is a positive charge, the electric field lines are always radially outward. For a single positive charge. For a single positive charge, then what happens here? The electric field lines are radially outward. These are radially outward. For a single positive charge. If I consider single negative charge, for a single negative charge. What is single negative charge? So here I am keeping a negative charge. If it is a negative charge, then the electric field lines are always radially inward. Radially inward. Radially inward. 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 So in this case, here I took straight line. The electric field will be along this direction. In this case, I took a curved path. If these are the curved path, the direction of the electric field can be calculated. Can be understand how? So at this point, the direction of electric field will be along this direction. At this point, electric field will be along this direction. Like this only, we can understand the direction of electric field. Then for third one, for a single positive charge and negative charge. One single positive charge and negative charge side by side. Okay na? Sorry, take positive charge both positive charge, let's take. Okay, if both are positive charge, here I am taking positive charge, here is also a positive charge. According to this charge, the electric field lines are radially outward. Okay, these are radially outward for positive charge. For this also, these are also radially outward. Then fourth property, if there is negative charge as well as negative charge, okay na? Here I am taking a negative charge, here is also I am taking negative charge. Then what happens? Here electric field lines are radially inward. Okay. If it is also a negative charge, then what happens? Inward. Okay. Fifth point is very important. Fifth point, one is a positive charge, another one is negative charge. One is a positive charge, another one is negative charge. Here I am taking a positive charge, here I am taking a negative charge. Then what happens? See here, it's a very important. I am drawing half of the portion over here. Okay. So from this point, the electric field lines are radially outward, is or not? Okay. From this point of view, the electric field lines are radially inward. Got the point? This point is very important. ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಗಳು ಯಾವ ಕಡೆಯಿಂದ ಬರುತ್ತೆ, ಪಾಸಿಟಿವ್ ಇದ್ರೆ ಹೊರಗಡೆ ಹೋಗುತ್ತೆ. ಆ ಪೋರ್ಷನ್ ನಾನು ಯಾಕೆ ಅರ್ಥ ಮಾಡ್ಕೊಂಡಿನಿ, ಈ ಪಾಯಿಂಟ್ ಇಲ್ಲ ಅನ್ಕೊಳ್ಳಿ ಸದ್ದ, ಈ ಪಾಯಿಂಟ್ ಇಲ್ಲ, ಈಗ ಈ ಪಾಯಿಂಟ್ ಇಲ್ಲ ಅನ್ಕೊಳ್ಳಿ. ಸೊ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಔಟ್ವರ್ಡ್ ಆಗತ್ತಾ. ಸಪೋಸ್ ಈ ಸದ್ ಈ ಪಾಯಿಂಟ್ ಇಲ್ಲ ಅನ್ಕೊಳ್ಳಿ, ಈ ಲೈನ್ ಇಂದ ಹಿಡ್ಕೊಂಡು ರೇಡಿಯಲಿ ಇನ್ವರ್ಡ್ ಆಗತ್ತಾ. ಸೊ ಇಟ್ಸ್ ಅ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಫ್ಯಾಕ್ಟರ್ ಹಿಯರ್. ಓಕೆ, ಸಿಮಿಲರ್ಲಿ ದೆನ್ ನೆಕ್ಸ್ಟ್ ಇಫ್, okay, then here also same, radially outward, for this radially inward, for this radially outward, radially inward, like this only the electric field lines will comes. Okay, so these are the very for 2 marks he may ask me a question. Okay, is important. From this we can conclude one very important of electric field line, properties of electric field lines, that is the electric field lines are starts from positive charge and end at negative charge. Okay na, then next only I will conclude the properties of electric field lines. Okay, first, what is electric field lines? Electric field lines either may straight or curved path in the electric field. The direction of electric field can be understood by drawing a tangent to the electric field lines. Okay, this is about electric field lines. For a single charge particle, radially outward, negative particle, negative charge, inward. If both are positive, outward, negative, one is, both are inward, then here one is a positive, one is a negative, then what happens, one is radially outward, one is radially inward. Okay, then next, properties of electric field lines. Next will be properties of electric field lines. Properties of electric field lines. Okay, now what are the electric field lines? Properties of electric field lines. First property I am writing. What is first property? The electric field lines starts from positive charge and end on negative charge. Okay, for example, see here, if it is positive charge, here is your negative charge, starts from positive point, end at negative point, negative charge. First, the electric field lines are always starts from positive charge and end on negative charge. Then second one is, the direction of electric field can be calculated. The direction of electric field can be concluded by drawing a tangent to the electric field line. See here, for example, if I am taking a curved line, electric field. I want to draw a tangent. It will be electric field. Direction of electric field at this direction. Then at this point, electric field lines. So electric field will be along this direction. Second property. Then third property. Third property is the electric field lines are never intersect. Okay, these are never intersect. What is never intersect? Say, I am giving you example. If it is positive charge, here is your negative charge. Always electric field lines are starts from positive end and negative end. And one more, electric field starts from positive end and end at negative end. These two lines may not intersect. This is an important point. See here, positive charge. Again, one more field starts from here and end at negative charge. These two lines may not intersect each other. Okay. Then fourth point. Come to the point of fourth. I will remove this. Fourth point. The electric field lines never formed closed loop. Closed loop. Okay. Never formed closed loop. How they never form a closed loop? See here. Again I am taking same positive. Here is your negative charge. What is closed loop? Closed loop means if a person starts from point A, again after making one round, if he comes to the point A again, it is your closed loop. Okay. In this case, what happens? Positive charge starts from positive, electric field line starts from positive end and end at negative end. ಇಲ್ಲಿದಿಂದ ಇಲ್ಲಿ ಬಂತು ಅಂದ್ರೆ ಮುಗಿದೋಯ್ತು ಅದರ ಕೆಲಸ. ಮತ್ತೆ ಇಲ್ಲಿದಿಂದ ಇಲ್ಲಿ ಬರ್ಲಿಕ್ಕೆ ಸಾಧ್ಯನೇ ಇಲ್ಲ. ಇಲ್ಲಿದಿಂದ ಇಲ್ಲಿ ಬರ್ಲಿಕ್ಕೆ ಯಾಕೆ ಸಾಧ್ಯ ಇಲ್ಲ? ಇಲ್ಲಿದಿಂದ ಇಲ್ಲಿ ಬರಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ ಇದು ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇದೆ. ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇದೆ ಅಂದ್ರೆ ಅದರ ಅರ್ಥ ಏನು? ಇನ್ವರ್ಡ್ ಆಗ್ಬೇಕಾ? ಹೌದಾ? ಔಟ್ವರ್ಡ್. ಇದು ಸಪೋಸ್ ಆಗಿ ಓಕೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಐತೆ ಅಂತ ಇಟ್ಕೋರಿ. ಇದು ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಆಗತ್ತೆ. ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಆದ್ರೆ ಈ ಫೀಲ್ಡ್ ಲೈನ್ ಕರೆಕ್ಟ್ ಆಗತ್ತಾ? ಯಾಕಂದ್ರೆ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ರೇಡಿಯಲಿ ಇನ್ವರ್ಡ್ ಇರ್ಬೇಕು, ಔಟ್ವರ್ಡ್ ಐತೆ. ಅದ್ರ ಸಲುವಾಗಿ ಏನಂತ ಹೇಳ್ತೀವಿ? ಇಟ್ ಈಸ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್. ಇಫ್ ಐ ಟೇಕ್ ಇಟ್ ಈಸ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್. ಇದು ಇಲ್ಲಿದಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗಲ್ಲ. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ? ಇನ್ವರ್ಡ್ ಇರ್ತೈತಿ. ಈ ಕಡೆ ಬಂದ್ರೆ ಏನಾಗುತ್ತೆ? ಔಟ್ವರ್ಡ್ ಆಗ್ತೈತಿ. ಆದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ ಬೇರೆನೆ ಐತಲ್ಲ. ಇದೇ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ ಬೇರೆ, ಇದೇ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ ಬೇರೆ. ಸೊ ಪಾಯಿಂಟ್ ಎ ದಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗಿ ಪಾಯಿಂಟ್ ಎ ದಿಂದ ಎವರೆಗೂ ಬಂತಾ? ಇಲ್ಲ. ಯಾಕೆ? ಇಲ್ಲಿದಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗಿ ಇಲ್ಲಿ ಮುಗಿದು ಬಿಡುತ್ತೆ. ಇನ್ನೂ ಒಂದು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ ಸಪೋಸ್ ಇಲ್ಲಿದಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ಆಯ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ಹೆಂಗ್ ಬರುತ್ತೆ? ರೇಡಿಯಲಿ ಇನ್ವರ್ಡ್ ಇರುತ್ತೆ. ಸೊ ಇಲ್ಲಿದಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗಕ್ಕೆ ಚಾನ್ಸೇ ಇಲ್ಲ. ಇಲ್ಲಿ ಯಾವುದೋ ಹಿಂದ್ಗಡೆಯಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಹೌದಾ? ಹಾಗಾಗಿ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ನಾವ್ ಏನಂತ ಹೇಳ್ಬೋದು? may not formed a closed loop. Okay. So next one, fifth, the electric field lines may not passes through conductor. May not passes through conductor. It is a fifth property. Then sixth property will be they may passes through what? Non-conductors. So these are the very important properties of electric field lines. For 3 marks he may ask. Okay. Then next, what are the formulas we have discussed? In the next lecture we will discuss some of the numericals based on this. So what are the formula? Today we got first formula is, write down this formula, very important. What are the formula? First formula, electric field. This E is equal to KQ divided by R square. Then second formula Second formula, what is that? This E is equal to summation of N is equal to 1 to N KQN divided by RN square. Okay, so next one more topic is there, significance of electric field. Okay, so after that we will conclude. Next is significance of electric field. Next is significance of electric field. What are the significance of? What are the significance of electric field lines? Sorry, electric field. See here. First significance is, let us consider this is your electric field. Okay. Inside this electric field, if I kept a positive charge there, if I kept at electric field on this, the force is experienced. What is that force? Electrostatic force is experienced on this test charge. So F is equal to, in the electric field, I am keeping in electric field, experiences a force on what? Q. It is a very, very important formula in further numericals. How it comes? First significance is tells us that unit positive charge is kept in the electric field, then force experienced on this test charge will be F is equal to E into Q. Then second significance is, it is important to understand what the electrostatic phenomenon. Okay, na? Significance or else importance also we can say. First is F is equal to E into Q. Second one, it is important to understand the electrostatic phenomenon. Then third significance is the force experience between these 2 point charges can be concluded by electric field itself. They are separated by some distance. Okay, na? Third one is, suppose here plus Q, here is also I am taking Q1, it is your Q2 separated by a distance 2. So between of these two there must be a force. How the force will be that? Because of electric field only we can conclude this. Okay, so what I told, the electrostatic force experienced between these 2 point charges separated by some distance can be concluded by using the concept of electric field. Okay, these are the very, very important significance. So tomorrow means in the next lecture we will discuss numerical based on this electric field. So what I told, first formula, E is equal to KQ divided by R square, then E net is equal to summation of N is equal to 1 to N KQN divided by Rn square, then F is equal to what I told, this formula, E into Q. Okay, na? These are the very, very important formulas. Okay, thank you. In the next class we will solve some of the problems.